Hello, good evening. Can you hear me?
Yes.
Yeah, how are you?
Hi. Fine, thanks. And you?
Yeah, I am fine. Thank you. Okay. Okay,
Great.
so hope you already get for previous material such as practice code and also get the recorded video class. Yeah. Did you get it?
Yes, I practice and I get some results with the code, the first code, with 1 or 2 points. But when I was trying to use a shapefile with many points, I had problems. But I think it's a problem with the recognition, that is a data frame, and I'm trying to resolve it, but I couldn't.
Okay, no problem. Let's
Uh,
discuss
I I
about
need
that
more
problem
time.
solving. Yeah.
I need more time, but I put in some images in the drive of the landscape analysis with some results instead of use them. I use bathymetry and I use line CUs and C cover classes, but I think there is a problem with the with categories of the land use and land cover, but I need more time to review it.
Okay, no problem. We'll also discuss. No problem. Okay. Okay, so today's session I discuss about that node analysis, network and node analysis, how we can easily perform
Mhm.
using different way. Okay, so let me share my screen. Okay, can you see my screen?
Yes.
So let's go. Okay, can you see my slide? Yeah.
Yes.
Okay, so let's go. Okay, so basically today's session I discuss about that network and node analysis. So basically network analysis is a method of studying and the structure and behavior of complex system by examining the relationship between the interconnected entities known as node or edge, or understand the pattern, identify the key players, or optimize network performance. Okay, so I'll try to explain all of those step by step and also show you the practical example how we can easily do this type of network analysis. We also discuss about that. So basically, first of all, we discuss about that what is network analysis, then importance in understanding the relationship and connection, and application, basically transportation. There are a lot of use for the network and node analysis, then also social network and also telecommunication, then ecological balance or ecology, and computer network. We are also use different types of network and also node analysis. And basically network, it's called the graph set of node mainly vertex and connected by link, and it's called the edge. And node, it can be different types of entities such as people, it can be cities, it can be device, it can be spaces. So different types of spaces when you work, then we talk about the different types of spaces. When you work with the cities, suppose for the transportation, so shortest part, this type of things we also discuss about that step by step. And is basically the relationship or connection between the nodes, it's called the S. And then there are the different types of network we find out, such as directed versus undirected network, then weighted and unweighted network, special and non-special network. So basically in this case we discuss about the special versus non-special network. Basically special, okay, such as geolocation. We have this type of network, such as road, then suppose point or polygon. So this type of a special feature, how we can easily analyze, we also discuss about that in this session. Then node analysis. So basically in the node, we just use this type of analysis such as degree centrality. It's mainly number of connections a node has. It's called the degree centrality. Then betweenness centrality, nodes role in the connecting others. It's called the betweenness centrality. And closeness centrality, how close a node is to all other nodes. And each vector centrality, it's important of a node based on the importance of neighbors. So all of those we try to analyze, and I'll show you the practical example. And basically network analysis mainly measures this type of things we measure, such as density, diameter, then clustering coefficient, then modularity. Okay, density, basically how tightly connected the network is. Okay, and diameter, mainly longest shortest path, it's a diameter. And clustering coefficient, basically tendency of node to from cluster. Okay, and modularity, it's mainly presence of communities or sub networks. It's called that modularity network analysis. And visualization example, we can easily import different size of node and diagram, such as OSM data. So further let's discuss about that, this type of things. And tools. Okay, so we are using the different types of tool for the network and node analysis. You can see the Gephi, so it's one kind of tool. Then network KX, basically this is the Python library. It also very useful to mainly monitor or analyze the network, as well as also R programming language. So basically in the R we use at the iGraph, or also use at the statnet packages. Okay, and Sidescape we are just use at the biological network, it also use. And Google Earth Engine we are also used for special network use cases. Okay, so let's I'll try to show you that this type of example, how we can easily work with the Python, how we can easily work with the R, okay, to analyze the network and node. We also discuss about that. And real world application, so use at that you can see social media influencer detection, traffic flow optimization, epidemic speed modeling, logistic and deliver route optimization, ecological food web analysis. Not only for that, there's a lot of application day by day we also find and also apply this type of things. And challenges in network analysis, basically large scale data handling we need to do. Then dynamic change. Okay, network very rapidly change, this type of network or this type of road very rapidly change, or dynamic change in network over time. Interpretation of complex pattern, and data privacy and ethical concern. Okay, so this is the major issue or challenges for network analysis. And future direction we also use at the real-time dynamic network analysis. Okay, as well as we will try to add the different types of artificial intelligence or machine learning, and application supports smart cities, IoT, or climate modeling. We can also do using this type of things. So let's go step by step. We try to discuss about that, how we can easily work with the network analysis. So first of all, when you make the network analysis for the geospatial analysis, suppose I need the road data. Okay, I need the road data. Basically, suppose you want to find out the shortest path or anything. Okay, so first of all, we need the road data. So basically, road data we can easily find out that Open Street Map. Okay, OSM data. So OSM data download. You can simply search, then you can see the Open Street Map. So for your study, you can easily find out that your all of road, such as major road, minor road, all of those we can easily get from here. So this is the Open Street Map. From here, you can easily find out. So for using this, you just need to log in or sign up in here. But in this case, we are also using one library. It's called the Python library. This Python library, we can easily access all of road network easily. We can get. So let's go. Okay, let me open the Google Colab. Let me just take the new notebook. So first of all, okay, so just I simply put the name. Okay, just so it's a network analysis. You can put any name. Okay, so then first of all, we need to install a Python library. Okay, so basically this Python library call, okay, just I install this Python library name mainly OSMN X. Okay, so it's one kind of Python library. It's is a powerful Python library. We can easily download the street network. Okay, as well as we can also download the building footprint, as well as we can also download the point of interest or other geospatial feature directly. We download it from the OpenStreetMap. Okay, so basically this is it's one kind of Python package, and it's very powerful. So using this package, we can easily download the street network, mainly road, then building footprint. Okay, so we can easily download it. So let's go try to install. So for installing, just use here the pip and then install and then put the package name. It's one kind of Python package. So just I run the cell, and this package mainly help you to getting the data. Okay, we can easily get all of open network data. Okay, road network data we can easily get from this package. I, in this time, suppose I just give a short name. It's a OSMNX. So I just call it as a suppose OX. Okay, so just I give a short name about that. Okay, it's not neat. We need to just import. Just I run again. So it's one kind of package we downloaded. We need the another package. It's called the network KX. Okay. So basically network KX, it's another kind, another Python library. So this network KX, basically it easy network analysis like shortest path or betweenness centrality. So just we just also install, suppose pip install, it's called the network X. Okay, so this is the another package. Okay, this is the another Python library. So basically this library help you to calculate different types of network analysis like as shortest path, betweenness centrality. Okay, different types of things we can easily do using this. So just I also install this package. Okay, it also done. So let's go try to import. So after install two packages OSMNX, then also install the network X. So now just simply import. So these two packages we just need to import in our cell. Just use here the import, and then I call the OSMNX, and I give a name. I put the short name, suppose OX. So further, when I need this library, I simply use the OX because I just rename it. Just import. Okay, there is no problem. And also import network. Okay, just network KX. I just call the Python library, and then I put the short name NX. Okay, so when I need this package, I simply call the NX. NX mix means the network KX, and OX mainly it means that OSMNX library. Just I give a short name. Okay, then just import. Okay, it's done. Okay, so now suppose I want to check the version OX, suppose OSMNX version I want to check. So for that, you can simply write the code ox mainly osmnx Python library, and put the dot underscore right here version, and then run it. So you find out this is the latest version about that osmnx library. So this is the way to check the version any Python package, or we can easily check it for the version. Okay, so now I want to download the data. Okay, so we need to download the data for our study area. Okay, so for that, first of all, you need to choose your place. Suppose I take a variable place, and then I simply mention the place. Suppose I need this data for Dhaka, just write the address. Suppose Dhaka metropolitan, it's Dhaka, Bangladesh. Okay, just I put the address, Dhaka metropolitan, Dhaka, Bangladesh. So suppose this is my address. So for this study area, I need the data, mainly I need the open street data or open street network or road network I need. So just I run it. Okay, there is no problem. Okay, so now just take the new cell. So now I need to download the data. Okay, and okay, so for that, just call the library. Suppose I just take a variable g, and then I just call the ox. Okay, so ox basically this is the Python package osmnx, and I call the ox. Okay, ox, it's my short name, I already give the short name. Just put the ox, and I put at the graph from place. Okay, it's one kind of function, graph from place, and I already stored the address which area I want to need. So just I put at the place, and I put this place in here. Okay, then network type. So network type can be different types of network we find out. So one, it's called the drive. Okay, drive mainly all drivable stress for the car. Okay, suppose road, private road, all of way. Okay, all drivable streets for car. Okay, so I also write the comment, it also more better. Suppose first one is the drive. Okay, it's one kind of mainly all uh, drivable drivable streets. Okay, and then we find out that another network type, it's called the drive service. Okay, basically drive service, it's another network type, all drivable streets including the service road. Okay, so all drivable streets including service roads. Then we also find out that another net, it's called the that walk, so only for the walking street. Okay, so walking path, it's the walking path. Then another network type, suppose bike. Okay, bike, so this is another network type. So bike mainly all bike friendly route. Then we also find out that all mainly including all of always. Okay, it including all ways. And for that, another network type, okay, just it's called that all private, all private. It's including always including the private access road. Okay, so always including private access roads. Okay, so basically this type of network type we are also use. You can see the drive. So drive mainly all drivable streets we find out. Drive service, walk, then bike, then all. So when you need, just simply change it in here, then you can easily get it. So now I need the data. So for that I simply, what types of data? Basically network type. I define the network type. Just I click to the run. So now it downloaded all drivable street. Okay, all drivable streets for my study area. I choose this study area, we can easily get. Okay, it's working. Okay, it's done. Okay, so we find out this type of. Okay, so now we try to plot it. Okay, and then check the result. So let's go try to plot. So just I use at the take a variable figure. I take a variable x equal. I just call the ox. Just call the ox dot plot graph. Okay, so just I, because all of road network or state network is stored in this variable g. Okay, just I call my function ox, basically osmnx library, and I want to plot this graph which is stored in this variable g. Okay, just I put at the g, and now if I just run the code, then check what happened. Just run the code. Okay, so we find out this type of road. Okay, and we also find out this type of as or nodes, but it not look more beautiful. Okay, so we try to add the more better visualization for. Okay, so let's go try to do it. So first of all, first argument, suppose bg color. Okay, basically background color we try to set. Suppose I set the background color as a white. Okay, and now if I just run the code, you can see what happened. We find out the background color as a white. Okay, it look like that. After that I want to add, suppose, node color. Okay, node color. So just I put at the node color equal, I just choose here red. I put the road color as the red, then click run. Or you can put any color, it totally depends on you. Okay, we find out this type of node color. You can see node show as this type of red color, but node size is very big. Okay, so that's why we cannot identify for edge or connectivity. We cannot understand, because you can see all of those show as a this type of node. Okay, we find out this type of point. Okay, so this type of red color indicating about the node. So now we try to decrease the node size, then it will be more better. Suppose I put here that node size equal, I put here suppose 1. Just run the code. So now you can see we can find out this type of node. Okay, in here we find out as well as color. Suppose I want to add the connectivity color or color, another color, suppose edg is color, just mention is color. I set this color as a suppose blue color. Okay, just run it. Okay, so now you find out this type of blue color, it's our edge, and this type of red color, it's indicating about that node. We find out the node. So this is the one way to download the data. Okay, so for any study area, using the same process, we just download our data, which data you want to use in here. So let's check the another example. Suppose I need the data for another study area. So for that, what can I do? Same process. Suppose I take a variable, I put the variable name, suppose place, and I set the place. Suppose I need this data for um, Berlin, Germany. Okay, just I put it Berlin, Germany. Just put the address. So now, suppose I need this all drive. I take a variable, suppose g drive, and I just call the ox. Okay, so ox graph from place, and I put mention the place. This is my place, and network type I put at the drive. Drive mainly it's including all drivable network. Okay, so just I run it and also run it. So now it downloaded all drivable network. It is downloading the data for the Berlin. Okay, it's done. Okay, now it's done for the Berlin. So now we try to suppose visualize the data. So same process, I just copy the same line which I already make the figure. Just I copy and then take the new cell and paste here. So now just I change the variable, just copy and also change it. Okay, just now run the code. So now it plot the Berlin in all of road network, mainly drivable. Okay, drivable network we find out, you can see. Okay, in the Berlin. Okay, so we find out this type of data. Suppose I need that all of walking street. Okay, I need the all of walking street. So for that it's very easy. Just I copy the same line of code. Just I copy and then take the new cell and paste here. So in this case, I simply change the network type. I need the network type. I need the suppose walking street. Just put here the walk. Okay, and now just run again. So now it downloaded all of walking street or walking network in the Berlin, Germany. It's working. I think that the dataset is very big, so that's why it takes some more time for downloading the working script for this study area. Okay, we try to continue. I just take the new cell. It also working, no problem. So we just working on this, suppose dryable script. Okay, so all dryable script. Okay, so now suppose I want to identify suppose shortest path. Okay, suppose the from here I want to find out the shortest path. This type of things. Okay, it's also done. Okay, let me show you the working state. Just I copy the code, same line of code, and then I paste here. Okay, so same variable is also no problem. Okay, but you try to use the different, then it will be more better. Okay, just run the code. So now it visualize all of working straight. Okay, it also plot. And I also find out that suppose GeoJSON. So this is one kind of website powered by Mapbox. Here we find out all of information, and you can easily generate the latitude, longitude, or feature collection or GeoJSON. You can easily find. Suppose I simply search here Berlin. Suppose this is our study area. Okay, so in the Berlin we try to identify suppose shortest path. Okay, from here to from here. Okay, I want to identify which is the shortest path. So for that I need the latitude longitude value. Okay, so for doing this thing, just click on here. You can see this is the, just click on the marker. Suppose this is my, suppose this is my study area. Just I click on here. So this is my starting point. Okay, and this is another. Suppose this is my okay, just I put here. Just I put here. Suppose this is my in point. So from this point to from this point, I want to find out the shortest drivable path. Okay, so this is my analysis. I want to find out which path is more shortest. Okay, so just I find out this is my start and this is my end. I find out in here. So let's go try to input these two latitude longitude value. Is simply import in our code. You can see this is the walking street. Okay, so there are a lot of we find out in the walking street, and this is our basically dryable. Okay, dryable street network, and this is the walking street network. As well as you also try to check further others. Suppose you can say I already write in here, so bike. Okay, so when you are use the bike, then we find out all of bike friendly route, then all private. So basically this is the different types of network type we also use in here. So now I want to identify for drivable network which one is the more shortest path. So just take the new cell in here. And I take a variable, suppose start point. Okay, start point. And now I just import here latitude and longitude value. Suppose I already find out the value from here to from here. So these two things I simply put in here. Just I copy this latitude and longitude value and paste here. And then another variable I take. Suppose I put the variable end point. equal. Suppose this is the another one for the endpoint. Just I copy the coordinate. Just copy this coordinate and paste here. Okay. So just I put here the latitude and longitude value for my start point and end point. And from this point, I want to identify which path is the shortest path, mainly drivable. Just I run it. Okay, just I import these two things. So after import your start point and end point, we need to create the node. Okay, node distance nearest node. Okay, distance nearest node we need to calculate for start point and end point. So for that, for just I take a variable, suppose start node. Basically we calculate distance nearest node. Okay, so just I call that ox. Okay, just I call the ox. Okay, ox, basically what is the ox? We already know about that. You can see ox mainly osmnx library. So just I put here the ox, and then I, okay, this it's not, we need to put here the distance nearest node. So just I put here the distance, then nearest nearest nodes we find out. For that, our for this road network, it is stored, you can see the g drive, this variable, just put in here g drive, and then mention here start point. Okay, so start point, I put in start point 1 and start point 0. So basically in this case we put here that 1 and 0, it's indicating about the latitude and longitude. So basically it's one kind of list. In this list there are the two items, 0 and 1. Okay, just I put here the start point 1 and 0, it indicating about the latitude longitude value 0 and 1. Same as we are also using here, just I copy these things, just I copy and then remove it and paste here. So just ox distance nearest nodes, then I put here the g drive, it is stored our all of drivable network. I put here the endpoint. Okay, endpoint 1 basically longitude, and endpoint 0 basically latitude, we just put here in here. So now I just run the code. Okay, there is no problem. So now we calculate the shortest path. Okay, so just I take a variable, suppose shortest path, and now when you calculate the shortest path, then we need the nx. Okay, nx basically network x, basically this library which I already imported, network x, this library nx. It calculate different types of network analysis parameter. So just I call the this library is yeah. So just call the nx and use the shortest path function. Okay, shortest path g drive, basically g drive mainly it is stored our all of drivable network. Okay, start node and in node. Okay, it already defined start node and in node. So just run it also. Okay, so now take the new cell, and now I want to plot the shortest path. So for that, just take a variable fig and also put here ax equal, we just call the ox and plot graph root. Okay, this is the function, plot graph root. I put here the g drive, basically g drive stored all of drivable network, and put here the shortest path. Okay, shortest path. Then you can see the route color, you can use the different types of color. Okay, or also put here the route line width, we can also use this type of things, or background color, node size. Okay, just I check the result. Okay, just on the code. it working? Okay, so let's check. Okay, so okay, let me check. I think some color is missing. Let me add later. This type of things I add the later. I just only point the shortest path. Only these things I want to print. Okay. Okay, it show this type of things. Is there any problem for, okay, let me check. Suppose I take the more another and then check. Suppose. I think I take the latitude longitude outside of Berlin. Okay, so that's why it not work. Then I put the more zoom. Suppose I take the new latitude again. Suppose from here to, so this one I just copy, and this is my start point. Use the square bracket, and after that I take the another one. So this one, just this one, just copy. Okay, now check again, run the code. There the square bracket, square bracket. then shortest path, and then plot. Okay, so let me add some other parameter. I think some for the background we cannot find out the short line. Okay, so just try to put here another argument. It's called that root line width. Okay, suppose I put here root line width. So I put here the root line width, suppose 6. Okay, now check again on the board. Let me change the background. Suppose put here node size. Node size, suppose I put here the 5. Then put here the background color. Suppose PG color white, and node color. Suppose I put here the yellow. So now let's check. Oh, it not show the short part. Okay, let me try for this study area. Okay, just a minute. Okay, just a minute. Let me check the combination. I think it's a latitude. So it will be first and then longitude. Then check what happened. Okay, so now it's right. Yeah, we find out. So first time we make the mistake in here. Okay, so first one is that latitude, then longitude, latitude, longitude. But when you just copy from here, we are not change. Okay, so first one is the latitude, then longitude. Just put in here, then it will be work. Yeah. So now we find out. So now you find out this is the shortest path. So we try to use the another. Okay, just a minute. Let me try to check for long distance. So first one, suppose I want to use, this is my start point. Just I copy and paste here, but we need to change. Okay, so this one is the first. Just I copy and keep at the first place. Okay, then use at the square bracket and also close. So same as second, suppose this one. So this one we keep the first place, and then this one is the second. So now I hope it will work. There is no problem now. Okay, so now you can see you can get this type of shortest path, okay, from this point to from this point. So you can also decrease the route line width, then it will be look more better. And also node size decreasing or decreasing. Also different types of background color. Then you also create the more better shortest path analysis. Okay, so first time we make the mistake for in the rearrange. Okay, just let it see longer reply, then it will be okay. There is no problem. Okay. So this is the one process we can easily find out the shortest path, as well as we can also calculate the degree centrality. Okay, so degree centrality, when you calculate, then we need to create some node. Okay, suppose you can create this one node. So how I can create the node, you can see this is the process to create the node. Okay, suppose you have some point. Okay, suppose randomly, so different types of latitude longitude, this type of start point, end point, so more than suppose 5 point. So now you try to create the node, and how I can create the node. So this is the process to create the node. Okay, so distance dot nearest dot nearest node. So this is the process we can easily create the node in here. Okay, so now if you want, you can also take that more node, just apply the same process. Suppose I, okay, let me add the more point. Okay, just I try to add. So now we try to discuss about that degree centrality. Okay, do you have any question? You can ask me any question or about that for shortest path analysis.
No, I think it's okay.
Okay, so first time we make the mistake to this rearrange. Okay, so then it will be okay, no
Yeah,
problem. Yeah, so any, if you have any two point, we can easily find out the shortest path from one location to another location.
yeah.
Okay.
We will saw other ways to obtain the same analysis or
Yes, it also possible to also use the R. Okay, so we also discuss about that how we can easily use the R programming to
mm-hmm,
calculate this type of things. But this is the Python. Basically, in the Python, we are just use the two library OSMNX and also use the network KX. So these two library
mm-hmm.
also use, and then we can easily calculate the degree centrality or anything, any network analysis. Okay, transportation networks or biological networks, social network. So this type of things we can also calculate easily using this two library. But it is also possible to also use the R programming. So how we can use the R using the different types of library, then you can learn it, no problem. So let's go. We try to discuss about what. Okay, in the degree centrality, we try to identify. So suppose I create some uh, graph or create some node. So for that, I just create a random graph. Okay, so not any specific location. I take the randomly. Suppose I take the G. I take a variable G, and then I just call that nx network x, and then create a graph. just apply the graph function. Okay, I create a graph. In this graph I want to add some node. Okay, randomly I add some node. So for that, just I call the G and add is from add is from, and then I simply put here suppose some point, suppose x and y. Suppose I put here, I just make a list and I put here suppose x and y suppose 1.2. So x1 y2. Then I get the another node, suppose randomly I put suppose 1 comma 3. Okay, suppose I put here the another randomly 2 comma 3. Okay, take the another randomly suppose 3 comma 4. Okay, suppose I put the another one suppose 4 comma 5. So just I create a random graph, and in this graph I add some node basically I add the point, suppose x and y. So I put the x value 1 and y value 2, so I create a point. So x value 1 and y value suppose 3. Okay, and practical example, when you do it for your geospatial analysis, then we need to take this type of, you can see we need to create, we need to take this type of latitude longitude value. After that we need to create the node. Okay, so and this is the process to create the node when you work with the geospatial data. Okay, geospatial mainly latitude longitude data. Suppose I take this one point, this is the another point. Okay, just we need to create the node. Okay, so one node, this is the another node, this is the another node, this is the another node. Okay, you need to create the node when you work with multiple location. But in this case I just create the randomly, I randomly create a graph, and this graph I add some node 1.2, 1.3, 2.3, 3.4, 4.5. I just create some random node. Okay, so now I run the code. Just a minute. What the problem? Graph has not okay. It show the problem. Graph has not attribute. Add is okay. So we make the mistake. It will be add edges. So now run the code again. Okay, it's okay, there is no problem. So we create some random node 1 2 3 4 5. We create the total 5 node. So now between the 5 node, suppose I have total 5 location. So this 5 node I want to calculate the degree centrality. Okay, so for that I take the new cell. Suppose I take a variable degree centrality. Okay, and call the nx degree centrality, and I put at the g. Okay, g basically it is stored at this type of node 1 2 3 4 5. It total 5 node is stored in here. So just run the code, it will be okay, there is no problem. So we find out the degree centrality, and then suppose I print it, just print this result degree centrality, then run it. So we find out this type of result here, you can see. So for the first 0.5, then 0.5, then 0.75, then 0.5, then 5, we find out the 0.25. So basically for the first node we find out the 0.5, second node we find out the 0.5, then third node we find out the 0.75, fourth node we find out the 0.5, and fifth node we find out the 0.25. Okay, so basically in network analysis, degree centrality is the fundamental measure used to evaluate the importance or influence of a node within a network. Okay, and it's particularly useful in understanding how well connected node, and which can indicate its ability to control the flow of information, resources, or influence within the network. So there are a lot different types of degree centrality we calculate. One is that degree centrality for the undirect network, degree centrality for direct network. So there are a lot of formula you can easily find out. And suppose interpretation, suppose I find out the 0.5, then 0.5, then 0.75, 0.5, 0.25. So we find out this value is high, 0.75 is the high. So high degree centrality, it indicating the nodes with high degree centrality are typically more central in the network and might have the greater influence, visibility, control. Okay, suppose in this case I have total 5 nodes, but I find out the which value is the getter. We find out the 0.75, if this is the highest value. Okay, so it's indicating about this node, basically third number node, this 2.3. So this location 2.3, this location or this node with high degree centrality. Okay, and it indicating the greater influence, visibility or control. Okay, so highly connected users are more in the spread the information from here. So between these 5 nodes, we find out that this node or this point or this location, we find out that it's the more influence, more visibility, or we find out that they are mass connection, better connection. Okay, so when you find out the high value, it indicating the this type of way, and low value, basically you can see we find out the 0.25. Okay, so 0.25 we can see this is the lowest value, 0.25. This low degree centrality, it means that node with low degree centrality might be isolated. So this 0.25 we find out that 4.5, this node is the isolated. Okay, or have limited interaction with the within the network, limited interaction, not mass, and which would indicate the less influence. So we find out that this one is for the less influence and this one is for high influence, because this one we find out the high value of degree centrality, we find out the high value. Okay, so I hope you can get the idea how degree centrality work. Yeah, so this is the way when you find out the high degree centrality, and these things you can also apply for geolocation also. Suppose you can create some random point, and this type of point simply convert into node. Okay, how I can convert the node, you can see this line of code, a start node and in node. So create this type of node, and then further between this node we calculate the degree centrality. And when I find out, suppose you can see for the first node 0.5, second node 0.5, third node 0.75, then 0.5, then 0.25. So for the third node we find out the 0.75. It's indicating about the high degree centrality, and high degree centrality indicating the more connected network. Okay, it more influence, it the greater influence, visibility or control. But low degree centrality, it indicating about that limited interaction, not mass, limited, and indicate the less influence, we find out that 0.25. So this is the way we can calculate the degree centrality and also measure and take the decision. Okay, so now another important part, it's called the which one, betweenness centrality. Okay, betweenness. So same process for the betweenness centrality, just simply take a variable. Suppose b2 betweenness, I take a variable betweenness centrality. Okay, and then you can say I just call the nx and use the function betweenness centrality. I want to calculate for the graph G. So for that, just I run it, and now print the betweenness centrality. and run it. So we find out this type of, you can see, betweenness, centrality. So betweenness, centrality, we find out that you can see the first node 0.0, second node 0.0, third node 0.6, fourth node 0.5, and fifth node 0.0. So basically betweenness centrality, it's indicating the nodes betweenness centrality is high if it lies may or the shortest path between the other pairs of node. Okay, that implies that the node control or influence the flow of information, resources, or other properties. So now high betweenness centrality, suppose I find out that high value for the third number node 0.75, it's the high, sorry, this one 0.66, we find out the high value, it's the high betweenness centrality. It means that nodes with high betweenness centrality are considered the brokers or gatekeepers, and they are important for controlling. Okay, they are important for controlling for communication or information flow across the network. Okay, and because may shortest path pass through them. Okay, so high value, high betweenness value, it's indicating about that as a gatekeepers. Okay, gatekeepers or brokers. Okay, they are important for controlling the communication. So this node is very important for the communication. When I find out the high value 0.66, it means that this node is very important for the communication or controlling the communication or information flow access through the network, because may shortest path through the others network. And low value, okay, so there it's not much important. Okay, because it's not work as a gatekeepers or brokers. Okay, low values centrality are less involve the connecting other node. Okay, so therefore less influence on the flow information across the network. So this is the way you can see high value indicating about that this is more better. Okay, and we can, and this node is very important for communication or information flow across the network. Okay, and low value it not much influence. Okay, so this is the way for betweenness and centrality. So I also send you some hand note. Okay, my PDF hand note or book. You also try to read it, then you also get the more better idea. So let's go try to, okay, so let's go try to plot it. Okay, so let's go try to plot. For the plot, I just need to import a package. So import matplot library as PLT. Okay, these things I also import, and then we are just plot. Suppose plot figure. Plot figure. I define the peak size, and then nx. I draw it. Nx draw draw. Okay, suppose I draw with levels 2 node color, we can put anything about that. Okay, just plot this node. What's the problem? Just okay, so you can see we can get the graph visualization. Okay, so now from this graph you also take the decision which one is more important. Okay, so this third number node is very important. Okay, because we find out that degree centrality value is also high, as well as we also find out that the betweenness is also high. You can see it's a middle planes, so all of node easily connected with this network. Okay, all of node you can see 1 2 also you can see 4 and 5, and less important, very less important is the 5. Okay, as well as also you can see the 1, also you can see the 2. So 3 is very important because 3 is the centrality is also high and betweenness is also high. Okay, that's why this node is very important for follow-up information and high influence for the communication. So this is the way we apply and calculate this type of things, okay, for the networking. And this type of things you can also apply for your geolocation. Okay, same process. For the geolocation, we just need to add the latitude longitude value, okay, and then create the node. This way, just apply and create the node, and then we can just apply this type of degree centrality, or also this type of thing apply. If you want, you can also apply for this type of, suppose I want to apply, suppose this one, there are a lot of node, okay, so then it takes some more time. Suppose I want to apply it in here, so for that just I copy and paste here. Okay, so now I consider all of node which stored it where, store it in the G drive, this variable. Okay, just I copy, just I paste here, and now run it. So now we find out that all of result degree centrality, just I print the result, print this degree centrality and run it. For the whole study area in the Berlin, Germany. Okay, so it consider all of node from here, all of node from here. Okay, all of node in the map. Okay, consider and calculate the degree centrality. Okay, I think there are a lot of nodes, so that's why it not work. But you also try, you just simply take some specific coordinate, okay, and further convert into node and then check. Then I hope it will work. There is no problem.